Hey boys and girls, so today we're going over Unit 8, Lesson 6. Before we get started, make sure you have your name at the top of the lesson. All right, so today we're going to be going over side, angle, side, 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 and angle, angle. All right, I'm going to get into those in a few minutes. First, let's look at the do now. It says determine if triangle ABC is similar to triangle EFD, justify your response. So I took one step ahead and I already boxed out the similar symbol and I wrote the definition. If two triangles are similar, that means that side length is in proportion and angle measure is preserved, right? Angle measure is equal in both. Well, I only know one angle in this big triangle. It's angle A. I know that that's going to be 90. And I also only know one angle in my little triangle. That's angle E. It's also 90. Okay, knowing that just these angles are equal wouldn't be enough. I'd have to also know that B is the same measure as F, right? C is the same as D. I don't know that information, so I can't use angle measure being preserved as an answer to say these triangles are similar. So that means I have to look at the side length, and I'm going to check to see if it's in proportion. I'm going to circle the smaller leg on this bigger right triangle, and I'm going to again circle the smaller leg on this smaller right triangle. I'm going to box the larger leg on this bigger right triangle. I'm going to box the bigger leg on that smaller right triangle. So I know that 3 and 1 correspond, they're corresponding sides, and I know that 5 and 3 would correspond as well. All right, so now I'm going to set up my proportion to check if those sides are in proportion. I gotta do that math and check it over. So I'm going to do my bigger leg to my smaller leg. All right, 3 over 1 equals, and then again, I'm going to do my bigger leg to my smaller leg, 5 over 3. All right, again, I'm going from big triangle to small, again, big triangle to small. You have to have some type of pattern when you set up the proportion. Then you cross multiply to solve. So here I go. 3 times 3 is 9. Equals is in the middle. 1 times 5 is 5. Whoops. I don't think 9 equals 5. So are those two triangles going to be similar? The answer is absolutely not. I'm going to say no, they are not similar. So no, they are not similar. Can anybody tell me why? Exactly, because corresponding, make sure you always use a vocab word when you're explaining. Corresponding side lengths are not, they are not in proportion. Okay, after I cross multiply, if these answers were the same, then I would have said, yes, they are in proportion, but since they're different, no, they are not in proportion. All right, let's scoot on up here to look at the bottom half of our notes. So sorry, guys. Whoop. All right. If I want to show that two triangles are similar, there's 3 different ways that I can do it, okay? If you think back to proofs, if I wanted to prove that two triangles were congruent, we had 5 different methods to pick from. If I want to now show that two triangles are similar, there's only 3 different proofs that will show that. Okay, this is called angle, angle. So let's fill in the notes on the side. Two triangles are similar if 2 angles of one triangle are congruent. If they're congruent to 2 corresponding angles of the second triangle. All right, and we're going to practice that today. Side, angle, side. If 2 triangles are similar, all right, they'll be similar if I have 2 pairs of corresponding sides, right, S and S, 2 corresponding sides that are going to be in proportion. All right, and we have 2 angles between them that are congruent. Again, if I'm showing 2 triangles are similar, those side lengths should be in proportion, but the angle measure is preserved, so the angle measures should be equal. They should be congruent. And then last but not least, side, side, side. Again, 2 triangles are similar if all 3 sets of corresponding sides are in proportion. Again, if 2 triangles are similar, we know that those side lengths should be in proportion. So again, all three sides should be in proportion. All right. All right, you guys, now we're looking at example 1 here, okay? So we're going to practice one of those similarity proofs right now. So as we look at example 1, it says, given that line segment AD and line segment BC intersect at E, AB is parallel to CD. All right, these two segments are going to be parallel. I'm immediately going to stop, and I want to just highlight out what's important here so I don't miss anything. So I know that knowing that those two lines are parallel is huge. I know that parallel lines form alternate interior angles. So I'm just going to box that out and write it on top. I should be thinking alternate interior angles for this question. And if you remember back, I have to highlight out the letter Z to find those bad boys. All right. And then the question says I want to prove that triangle ABE is similar to triangle DCE. Just for this question, I'm also going to highlight out the similarity symbol, just because, again, I should only be thinking of the 3 proofs from the first page right now. That was the angle, angle, side, angle, side, and side, side, side. All right. So here we go. Before I start marking anything on my picture, I like to get that first step out of the way, which is the given. So I'm going to just write number 1, right? First step on my statement reason table. So given that those two segments intersect at E, I can add that on. AD and BC, those two segments, they intersect. That means they cross at E. Knowing that they cross isn't really important. Intersect isn't a true vocabulary word, so I'm going to skip that. And I know this is really my big piece of information right now. Line segment AB is parallel to line segment CD. How do I know all of that? Because it was given to me. Step 2. Well, step 2, I don't know what that's going to be yet. I have to start marking my diagram in order to figure that out. All right, here we go. I should be thinking again that letter Z. So I'm going to either start highlighting out a regular looking Z or a backwards looking Z. I don't have to mark that these lines are parallel because they were already marked for me with that little arrow. All right. I'm going to make a regular looking Z to start. So I'm going to highlight out my parallel line. I'm going to make my way down so that way I'm ending on my parallel line. And now I'm just going to mark out angle C and angle B with 1 arc on each to show that they are equal. And then I'm just going to go ahead and I'm going to mark out that backwards Z as well. Just get it all done right now. So again, I'm on my parallel line. I make my way all the way down so that I end on my parallel line. This I'm going to put 2 arcs on. Again, this I'm going to put 2 arcs on. They're different angles. They should get different markings. And now I'm going to add those congruent angles that I just marked onto my table. As soon as you mark something, you want to add it on. So here's going to be my step 2. Just going to slide my paper up a smidge. Step 2, I'm going to say that angle DCB, I'm really talking about angle C. That's why it's in the middle. That's where my vertex is being formed. I know that's going to be congruent to angle ABC. Again, I want angle B to be in the middle because that's the angle, that's the vertex that I'm talking about. All right. I can also go ahead and in the same step say that D and A are congruent as well. So I'm going to do that now. So I'm also going to say that angle CDA, CDA, D is in the middle because that's the vertex I need, is going to be congruent to angle BAD. Angle BAD. A is in the middle because again, that's where my vertex is being formed. Now you guys know by this time around that I can name angles with 3 letters multiple different ways. All right, so this is just how I'm choosing to name C and B and D and A. All right, as long as those outside letters form that angle you're looking for, you're going to be good to go. All right, how do I know these angles are equal? Anybody? Anybody? You're absolutely right, because if I look back at my given, what do parallel lines form? Alternate interior angles. All right, so anytime I'm giving a reason, I have to use a vocabulary word, and it's always got to be that word that they kind of gave you, all right, from the start. So here I go, step 2, parallel lines because again, that's the vocabulary word they gave me in my given. Form, what do they form? They form congruent, alternate, interior angles. All right, make sure you write all this down. You want to get full credit for this question. All right. So now I have to think back, well, that's all parallel lines do. I already found both pairs, so there's really nothing else that I can, like, nowhere else I can go from here. So if I think back to the first page, I'm just going to bring that back on camera for a quick second here. And you look at the bottom, we know there's 3 ways to show that 2 triangles are congruent. I didn't say anything about the side lengths in this example because they didn't give any information about them to me. We only talked about angles. So I should be trying to use the angle proof right now. And that says if I have two angles in one triangle that are congruent to 2 angles in another triangle, I have angle. Well, let me look. I have angles C and D in the little guy being equal to angles B and A and the big guy. So am I done? Yeah, I am. So I'm going to go ahead and move on to step 3, which is going to be my proof. Triangle ABE is similar to triangle DCE because of angle. All right, that's the method that I'm using to show that those 2 triangles are similar. And that's how you would do a similarity proof. All right, let's just move on down here to the bottom question. Make sure that you guys can see it all with me. All right, here we go, example 2. It says determine if triangle PQR is similar to triangle XYZ. Again, I'm going to go back and I just want to highlight out that similarity symbol. That's important. If 2 triangles are similar, that means sides are in proportion. Angle measure is equal. Okay. Well, I don't know anything about the angles in these triangles, so I can't use like an angle proof like we did a minute ago. So I should be thinking like side, because that's what they gave me. All 3 sides in the first triangle, all 3 sides in the second triangle. All right. So I'm just going to use that method we used in the do now. I want to see what's corresponding here. So I'm going to circle the smaller side in the large triangle, and I'm also going to circle the smaller side in the little triangle. I'm then going to box the medium size in the large triangle. I'm going to box that medium number in the little triangle. And then I'm just going to underline the largest side, and again, I'm going to underline the largest side. So I know that these guys will correspond. I know that these guys correspond. And again, these guys correspond. So now I have to set up some type of proportion to check to see if those are in proportion or not. All right. So I could either, again, set up a proportion, or I could just check to see what the scale factor is. All right. I'm going to do the scale factor just because it's going to be a little bit quicker. And it's good for you to know 2 different ways to get that missing answer here to see if those sides are in proportion. So I'm going to do my larger triangle on my smaller triangle. So on the side here, I'm going to set up 3.6 over 2.7. I'm going to do my image over my pre-image. Okay, this is just how I'm seeing it. I'm going to go from big to small here. So when I divide these guys and I check what the scale factor is going to be in my calculator, it's either going to be 1.3, right? It's going on forever. So I'm going to say it's 1.3 with a bar. Or if you have a graphing calculator app or the graphing calculator at home and you want to turn that into a fraction, it's actually 4 over 3. Okay, so you can write either one of these and you're going to be correct. So now I'm done with the circles. I'm going to go for the boxes here. Again, I'm going to go from my big box to my small box. All right, so I'm going to do 7.28 over 5.46. Again, when I type this into the calculator, I get the decimal 1.333333, right? It's repeating, it's going on forever. So it's 1.3 with the bar, or again, if I turn it into a fraction, it's 4 over 3. And now I have to check all 3 sides. Just because these are equal doesn't mean that this last side length will be. All right, so I got to check it. Again, I'm going to go from my big to my small triangle. I'm going to do 10 over 7.5. When I divide those out, again, in the calculator, I'm getting 1.3 repeating. Or if I turn it into a fraction, it would have been 4 over 3. So you can write either one of these answers, either the decimal form or the fraction form. But since all three are the same number, are these two triangles similar? Yes, yes, they are similar. How do I know they're similar? Because all three pairs of corresponding sides, or really corresponding side lengths, are in proportion. All right, and because all three corresponding side lengths are in proportion, this is really showing the proof of side, side, side. So I'm going to say they are similar by side, side, side. These sides are in proportion. The circles are in proportion, the boxes and the lines, right? All three sides are in proportion, so I know I'm good to go. All right, this is the method that I would have used to check to see if, again, those triangles were in proportion. I could have also literally set up 3 proportions like we did in the do now. I could have done circle over circle equals box over box, cross multiplied and solved. Then I would have done box over box equals line over line, cross multiplied and solved. And then again, I have to go all the way around. Then I would have did line over line equals circle over circle. I would have made my way all the way around the triangle, setting up 3 proportions and checking when I cross multiply. Do I get that same number each time? And again, you would have seen that the answer is yes. All right, but just for time, this is faster. So that's why I just checked the scale factor. And it was the same, so those triangles are similar. All right, if you guys flip and you go to the 3rd page here, this is now just going to practice everything that we just went over. A question like we saw on example 2, and then a question like we saw on example 1, a proof. Okay, I want you guys to work on 3 and 4 on your own, just like you would if you were in school. You got to practice by yourself. And then when you're done, feel free to check back in the video to see if you got those answers correct. All right, so as we look at example 3, it says determine if triangle ABC is similar to triangle ADE, explain your answer. So anytime we see that keyword similar, right, or the symbol for similar, it says side length is in proportion, angle measure is preserved. So I like to just write that right away so that way I don't forget it. Anytime I'm dealing with similar triangles, or even if I'm trying to prove that 2 triangles are congruent, if the triangles are overlapping, like this picture here, this diagram, I don't know about you, but it helps me to separate them. So that was just something I did right off the bat. I can see that angle D and angle B are equal. They're congruent in both triangles because they have the same angle measure. So when I separated it, again, I just continued that one arc on both to again show that they're equal. And again, now that I redrew them separate, it becomes very clear that angle A is also in both triangles here. So I marked that with 2 arcs. It's a different angle. It gets different markings. All right. So now I have 2 pairs of corresponding angles, and that's enough to say that yes, those triangles are similar, because 2 pairs of corresponding angles show that those triangles are similar. And I know that they're similar by angle, that proof. All right. Just as a refresher, when the triangles are on top of each other, like the original diagram, I would have said that angle A is reflexive. All right, because it's the same angle in both. All right, that was example 3. Let's look at example 4. Example 4 was a little bit more challenging, but I really wanted to see what you guys were going to do on your own before I just went over it with you here. So again, example 4, there's a lot going on here. Just looking at the diagram, it looks very busy. So as I'm looking at the prove, I'm seeing that it's triangle DEF and BGF that I wanted to show that were similar. Again, I'm seeing that symbol for similar. So I highlighted the 2 triangles out that I needed from the start, just because, again, that helps me visually see what the goal is for the question. Now I'm going to look at the givens. Parallelogram A, B, C, D. That's this big shape right here, all right? I have line segment, right, EFG, and I have diagonal, which is again that line segment DFB. So I can see I have my diagonal, I have that segment EFG, all right? And then again, I know that the entire shape is a parallelogram. I want to show that it's these two triangles that are similar. First step, you always want to add the given to your table, which I did. Now, it might look like they didn't give you enough information to solve, but really they did, because parallelogram is a huge vocabulary word. There's a lot that happens in a parallelogram. Both pairs of opposite sides are equal. Both pairs of opposite sides are parallel. Opposite angles are equal. The diagonals bisect, right? I could go on and on here, okay? But the only piece of information that I really want is the fact that opposite sides are parallel. Because what do parallel lines form? Alternate interior angles. All right, so that's really the piece of information I wanted. So the second step in my proof would have to be that opposite sides are parallel. So I could have said that AD is parallel to BC, again, like I did. I could have also listed that DC is parallel to AB. All right, I don't know if that would have helped me as much, so that's the only reason I left it off, but I could have absolutely added it to my table and not have gotten any points taken away. Well, how do I know that those two lines are parallel? Because in a parallelogram, opposite sides are parallel. All right, so I have to include step 2, or else this proof would have technically been incomplete. So now that I know those line segments are parallel, I drew a little arrow on both just to, again, show that they're parallel. And now I can go ahead and highlight out my alternate interior angles with that letter Z. So I made a Z in pink on my parallel line, making my way down, so I end on my parallel line. And then I did it again in blue. I started on my parallel line, made my way over, so I ended on my parallel line. All right, highlighting out those triangles helped me realize that those are the angles I needed to show were equal. I made one Z in pink, one Z in blue, and then I arced out those angles. One arc on D and B, 2 arcs on G and E, right? Different angles get different markings. So now down here, step 3, I just listed it's D and B that are equal and E and G that are equal. Again, you have to name those angles with 3 letters. How do I know they're equal? Because parallel lines, that's the vocabulary word, form congruent alternate interior angles. And again, now that I have 1 pair and 2 pairs of corresponding angles here that are equal, I know that those triangles are similar by angle, angle. That's the proof I was going to use. All right. I could not have used side angle side or side, 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 because I have no idea what any of the lengths of these 2 triangles are, and that wouldn't have helped me. All right, as you look at the homework, the independent practice on the last page, number 1 is another proof. Again, do your best. Try to look for, those parallel lines. They form those alternate interior angles. Again, this looks a little bit busy, so if you want to, again, just highlight out these 2 triangles so it's a little bit clearer to see what you're dealing with, that's fine. If you don't have a highlighter and you just want to scribble out the 2 triangles, that might help as well. And then number 2 is, again, determine if those triangles are similar. You got to use some math here to see if these side lengths are in proportion. All right, and you're going to have to identify what sides correspond. Is it 2.24? Does that correspond with the 6.32? Or does it correspond with the 4.48? All right, be very careful when you set up your proportion on the side here, or when you divide to check for that scale factor. Okay, you can either use the method I used on the do now proportion, or you can use the method I used on example 2, which was checking the scale factor. Okay, either one will work. All right, have a great day.